about a very important topic related to the foundation engineering, which is the Meyerhof bearing capacity equation or the Meyerhof bearing capacity theory. We discussed previously in our previous lecture uh, Terzaghi's bearing capacity theory, but I will give you a brief overview that what we discussed in our previous class. First, we started with understanding the ultimate bearing capacity of soils, which we defined as the least pressure which would cause the shear failure in soils. So it's the least pressure which would cause the shear failure in soils. Then we move towards understanding various modes of shear failures. For example, general shear failure, local shear failure, and punching shear failures. Then we move towards understanding the key terminologies related to the bearing capacity of shallow foundations. For example, we study about the gross pressure intensity, and which we defined as weight of superstructure, weight of foundation, and weight of backfill soil divided by the area of the foundation. Then we moved towards the net pressure intensity, which was defined as Q gross minus Q, or we can also write that as gamma into D. Then we defined the Q safe, which is basically the ultimate bearing capacity divided by the factor of safety. And factor of safety for shallow foundations, we usually take 2.5 to 3 based upon various uncertainties in soils and the loading condition. Then Q allowable was defined as the minimum of Q safe and minimum of the Q settlement criteria. This will give us the Q allowable. After defining the key terminologies, then we discussed about the bounds method, and we discussed about the Q ultimate using the lower bound solution. It was 4C plus Q, and for the case of for the upper bound solution, it was 6.28C plus Q. Then we moved towards discussing the Terzaghi's bearing capacity theory, and we find out that we can write the Terzaghi's bearing capacity equation this part contributes due to the cohesion of soil. This part contributes to the ultimate bearing capacity of soil due to the overburden pressure exerted on top of the footing, and this part contributes due to the soil weight or weight of soil. I would say weight of soil. Excuse me. Now we also discuss the effect of water table, that how the bearing capacity would change if the location of the water table would vary along the depth of the foundation. Now in today's class, we are going to discuss the Meyerhof bearing capacity theory. Okay, first of all, this is the extension okay, if I got disconnected, the one who is having my number, I guess Hamid is having my number, so Hamid or the CR can call me, please. If I'm disconnected or for some reasons you are unable to hear the voice or the screen is not visible, please kindly do call me as soon as possible so that we won't repeat the lecture again. So it happened for a few minutes in the previous class. Now, this is the failure mechanism for Meyerhof bearing capacity equation or theory. So we were discussing about the extension. So this is the extension of Terzaghi's bearing capacity theory, and it accounts for the moment or eccentricity and also for the load inclination effect. For example, if we have a footing and this is the center of the footing and the load P is eccentric, and I would call that as E. So a moment would be created, and this effect was incorporated by Meyerhof. While in case of the Terzaghi's bearing capacity equation, the P load or the eccentric effect was neglected. Similarly, if there is a horizontal, or we call that as vertical load, and we are exerting horizontal load as well onto the foundation, there will be a resultant which will be acting at a certain theta, and that theta is known as the inclination angle. Basically, these moments are the inclination will reduce the bearing capacity of soils. So these effects were taken by the Meyerhof bearing capacity theory.
सर ये हॉरिजॉन्टल किस तरह रिजल्टेंट बनाता है
Sorry,
सर ये फोर्स जो लग रहा है ये हॉरिजॉन्टल है सर, तो इसकी रिजल्टेंट किस तरह बनती है?
ये हमारे पास हॉरिजॉन्टल फोर्स है, ये हमारे पास वर्टिकल फोर्स है, तो इसका जो रिजल्टेंट है वो यहाँ पे एक्ट करता है। अब ये हॉरिजॉन्टल जो हमारे पास लोड है, दैट इज ड्यू टू दी विंड लोडिंग, और वर्टिकल जो लोड है वो हमारे पास डेड लोड और लाइव लोड की वजह से एक्ट करता है। Now here we are given with the two mechanism, failure mechanism. This one is the Terzaghi's bearing capacity theory failure mechanism, and this one is the Meyerhof bearing capacity theory failure mechanism. Now there are few differences here. For example, in case of Terzaghi's bearing capacity theories, this alpha was equal to the friction angle, which we usually derive or we get from the direct shear test or the triaxial test. However, in case of the Meyerhof bearing capacity theory derivation, you need to consider that this angle alpha is equal to 45 plus phi by 2. In the second difference would be that if you see the slip surface, so here is the slip surface. For example, this was the zone 1, zone 2, or zone 3. You can clearly see here that this is the foundation level and here is the ground level. So this is the footing on which the pressure is applied. Now the shear strength of this part of the soil was not considered in case of Terzaghi's bearing capacity equation. However, if you see here, This is the failure surface or the slip surface, and we can clearly see that the shear strength of soil is taken into consideration in order to derive the bearing capacity equation here. Now, this is the bearing capacity equation. Don't get frightened by the length of the equation, because the basic equation remains the same. If you see here, so it's the C and C, Q and Q, half gamma B prime into N gamma, and D, S and I. D represents the depth factors, or DC, I would say DC, D, Q and D gamma represents depth factors. SC, SQ and S gamma represents the shape factors. IC, IQ and I gamma represents the inclination factor. Now this B prime we will explain later. It is the effective width of foundation. Here are the bearing capacity factors: NC, NQ and N gamma. We can find the required or the desired bearing capacity factor if we have the friction angle of that soil. So that these are also dependent upon the friction angle. Then we can also find out the, okay, please note down this equation. It's very important from the exam point of view, from the quiz assignments point of view, and for general understanding and for the designing of the foundations. And please also note down the equations to find out the bearing capacity factors and the shape factors and the inclination factors, because we are going to use all these equations somewhere in solving exam problems or the assignments problems and numericals. Okay, now these are the bearing capacity factors and these are the shape factors, and you can clearly see that Kp is the lateral pressure coefficient in case of the passive condition, and that is equal to this equation. B prime and L prime, these are the effective width of the foundation and effective length of the foundation, which we are going to discuss in the coming few minutes. Now, depth factors can be found out using these equations, where D is the depth of foundation. These depth factors account for the increased bearing capacity of the foundation at greater depth. Now, additional strength is provided by the soils above the level of the foundation. Now, you might be wondering that how come we get these equations and how we reach to these equations, or how Meyerhof can derive these equations. So I will show you a glimpse of how we get to these equations in research and academia, which is related to, so I have already shared a paper related to the numerical study on the bearing capacity of shallow foundations based upon Meyerhof methods. So let's go through that if I can find somewhere. Yes, here. Now I need 3 volunteers so that they can read that paper, the highlighted text there, and then we will discuss. Okay, I will address the questions at the end of the lecture. Yes, questions are remembering. It's a good question. Yeah. Okay. Was that? Osama. Okay. Osama is the first volunteer, and who will be the second volunteer for reading out the text there. Okay, Hamid, can you help me out in reading the research paper? The highlighted text only. And I need a stable connection as well so that we won't be having any issue with the voice. So I need 2 more volunteers. Sajad Khan, okay. Who is the third volunteer? Okay, I don't have the third one, so let me start with the. Whenever you do research, whenever you do or perform a model test, for example, if you are performing a frame structure, so that would be related to the structural engineering, and we bring it to the shaking table, and then we investigate the dynamic effect and how much damages that structure experience, and then we write a research paper and we comment on it, that what happened on what cyclic loading or frequency levels. Similarly, in bearing capacity equations derivation, there is a history that how it started and who started the derivations and the failure mechanism. So here is a technical note. First of all, this is a technical note. A technical note is a short paper compared to the extensive paper. And here is the journal where it was submitted and all the information. So it was submitted in and accepted in 2018. Now here is the title of the research paper. The reason I am sharing this info, first of all, it's related to the Meyerhof bearing capacity equations. It's also helpful for enhancing your knowledge and understanding on the bearing capacity equation. But the other objective is that if someone is interested in performing the numerical study related to the shallow foundations or even the model study, like the physical models, and we can test these kind of models, and then we do the numerical simulation as well, numerical modeling as well. It can help you in finding the scholarships related to geotechnical engineering, because if you do the FYP in geotechnical engineering and if you pursue masters in geotechnical engineering, then the supervisors internationally, they usually see your CV with care and very seriously. They take it very seriously because you have done the research during the undergrad related to that field. So that's why I'm sharing this info. So if someone is interested to perform the numerical or model testing in shallow and deep foundations, they can contact me through my email if they got interested. If your interest and my interest matches there, then we can move on the related projects. For example, BARS in 2017 submitted this paper, and now Mohammed Osama, please kindly help me out here with the highlighted text written in the abstract.
Most geotechnical codes and books use the equation of Meyerhof or Terzahi to calculate the shallow foundation. These equations are based on the failure mechanism published by Prandtl for shallow strip foundations. The common idea is that failure of a footing occurs in all cases according to
Okay.
Prandtl-Witch failure mechanism.
Okay, please wait. Now, please wait. Now, you can clearly see here that Prandtl was the researcher who did or who started research on the strip foundations. And if you remember, in case of Terzagi's bearing capacity failure mechanism, we were told that this part is the elastic wedge, and then there is a radial zone, radial shear zone. In fact, Terzaghi named that radial shear zone also as Prandtl zone because he was so much impressed from his work, so that's why he dedicated this zone 2 to Prandtl. Okay, now you can start from to check, please.
To check the failure mechanism and the equations of the currently used bearing capacity factors and correction factors, a large number of finite element calculations of step and circular footings have been made.
Okay, please wait. Now, finite element calculations, so it's an FEM software, and the name of that software is Fluxys, and it is available in 2D and 3D as well, where you can perform bearing capacity analysis for shallow and deep foundations, and which is used in North America in the consultancy firms as well, as I mentioned earlier, related to the GeoStudio. So that is another software which is widely used in the industry. So please kindly watch or download this software. The videos are also available on the internet, and I will show you a few glimpses of that as well. Now the finite element calculations, you can start, Sama, please.
The finite element calculations show that in case of the soil with high friction angles, soil without cohesion or subcharged footings with inclined loading or circular footing, not the Prandtl-Witch failure mechanism, but other failure mechanism occur. In addition, the currently used equations for the bearing capacity factors and the correction factors are too high. Therefore, new equations have been presented in this article. For some correction factors, for example, the inclination factors and the cohesion slope factor, an analytical solution is found.
Okay, thank you. Now, when this research is It's conducted in 2017, so fairly recent, I would call that. And they are evaluating the strip foundations and circular footings here. Okay, and they are working using the FEM analysis, and they are commenting on the very fundamental concept of the Prandtl failure mechanism for cohesive and cohesionless soils. So that's how the research is done. Now the Prandtl wedge, please. Please, the origin.
Prandtl wedge. The origin of the design of shallow foundation leads back to the publication of the mechanical engineer Ludwig Prandtl in 1920 called About the Hardness of a Plastic Body.
Okay, the publication.
The publication of Prandtl was meant to find out at which load pull plasticity would be reached, allowing an object to be fully pushed into a solid body. The civil engineer Hans J. Reisner recognized in 1924 the importance of the Prandtl solution for the foundation engineering and translated into an analytical solution for the bearing capacity of a soil under a load P.
Okay, please, thank you very much, Osama. Now you can see there is another researcher who came up here, and he also presented the analytical solution for the bearing capacity of soil under a load P. Then he also considered the strength of the soil as the angle of internal friction phi and C. The original drawing of the failure mechanism proposed by Prandtl can be seen in figure, showing those three zones: the elastic zones, the Prandtl zone or the radial shear zone. This is the failure mechanism proposed by Prandtl, and how he derived the equation for the ultimate bearing capacity as well. In fact, it was Terzaghi's who did that. So he proposed the, now volunteer number 2, Sajjad Khan, please.
The solution of Prandtl was extended by Reisner with surrounding surcharge Q, curling. Weissman and Terzaghi extended the Prandtl-Reisner formula for the soil weight gamma. It was Terzaghi who first wrote the bearing capacity with 3 separate bearing capacity factors for the cohesion, surcharge, and soil weight. Merhope was the first to propose the equation for.
Please wait. So the Terzaghi's contribution in the research is that he proposed 3 separate bearing capacity factors for cohesion, surcharge, and soil weight. Okay. Now, for the today's lecture, we are going for the Merhof. So you can continue with the Merhof contribution, please.
Merhope was the first to propose equation for inclined load based on his own laboratory experiment. He was also the first in 1963 to write the formula for the vertical bearing capacity PV with bearing capacity factor N, inclination factor I, the shape factor S for the 3 independent bearing component cohesion C, surcharge Q, and soil weight gamma. In a way, it was adopted by Brinch Hansen and can be found in most geotechnical design code and books.
Okay, thank you very much, Sajjad. Now, Merhof bearing capacity theory is used, or in the name of using the name of the Merhof in North America. However, Brinch Hansen in 1960s and 70s, he proposed few modifications to the sloping ground So in Europe, they called Hansen's equation, okay, or bearing capacity theory, because he has modified that. So Europeans, they called Hansen's bearing capacity theory. But the idea, the concept behind these derivation remains the same. It started from Prandtl, Reisner, Terzaghi, Meyerhof, and then Brinch Hansen. There is Vesic as well for the case of sloping foundation then. So he proposed different bearing capacity factors. So coming back to the research paper, so he used these bearing capacity factors, and then he compared it with the Plux's software, okay. He did the numerical check, he measured or he plotted and investigated the displacements, load displacement curves there. He plotted the angle of internal friction and the bearing capacity factors, how it affects as the angle of internal friction increases, what is the effect on the bearing capacity factors. Then you can clearly see here that three different types of zones can be clearly seen if you perform that analysis, if you run the analysis using the Plux's 2D software. So it is the Plux's 2D software, very powerful if someone is interested in geotechnical engineering. And we can clearly see the researcher is saying here that for phi equal to 20 degree and cohesion equal to 0 kilopascal, then you can see a clear Prandtl wedge failure mechanism. However, when the density of the soil increases, the friction angle will increase, and you will see that only elastic wedge can be seen in case of the high frictional soil. So these are his findings and recommendations, and he also investigated various inclination factors there. And we can clearly see the model tests which are performed. For example, some asked about the question here. So you can see here, this is the theta, which is the inclination angle, which is having a vertical component and a horizontal component, or if the inclined load is applied, it will be having a vertical component or a horizontal component. So that's how we perform the model tests, okay. And this angle basically is known as the theta, or the inclination angle, and we can measure that as using the LVDTs as well. Here is a box which will create boundary condition, and this research needs to be done at UET Peshawar as well, because this is related to geotechnical engineering. Someone needs to come up so that we can do this research. This is very fundamental research, and the fundamental research is always exciting because we are trying to figure it out. First of all, you learn a lots of things, because if you are working on the bearing capacity, so you can also contribute in the designing as well. And if you want to prepare or fabricate these models, physical models, so definitely you will be notice there that this person is doing research in the field of geotechnical engineering, which is in itself a unique field, I would call that, currently at the Department of Civil Engineering. Now, that's related to the inclination, and which for inclined loads, mole circles, we are going to use these concepts, and the shape factors as well, different shapes of the foundations. If the inclination angle is 0 degree, 5 degrees, so we can prepare these models. I can support the financially there if you want to prepare these models. So That's also possible. You don't need to worry about that as well. Shape factors, you will use these shape factors, and then you will notice that how the failure mechanism for a circular areas, for a rectangular footing, for a square footing will change beneath the foundation. So you can clearly see that significant stresses are applied near to the foundation, and as you move below the foundation, then the stress intensity is decreased. And also the friction angle characteristics has been made that friction angle is 0 or for cohesive soils, and if we are having purely frictional soils or the internal friction angle is very high, then how the failure mechanism would occur. Slope factors are also investigated by the Hansens after the work of the Hansens. These are the slope factors which were incorporated in the equation. The failure mechanism was suggested. It's kind of a curved one, which can be seen. This is the zone 1, zone 2, zone 3. And here is the sloping ground beta, example 10 degree or 12 degrees. After that, yes, here is the sloping ground, so you can clearly see the sloping angle changing and how the failure mechanism beneath the foundation is changing. So this is one research area or the concept which we can target during your final year project. Okay, the third volunteer. Who is the third volunteer? He needs to help. He or she needs to help me with the conclusions, please.
Yes, sir.
Name, please.
Amna Khan.
Okay, thank you. Please start with the conclusions.
A large number of finite element calculations of strip and circular footing on a homogeneous soil have been made to check the failure mechanism and to check the currently used equations for the bearing capacity factors and the equations for the corresponding inclination factors and shape factors.
Okay, so these are the factors which were investigated during this study.
And slope factors, the finite element calculations show that the currently used bearing capacity factors are too high. The most important reason for this is that for natural soil, the latency angle is much lower than the fraction angle. The finite element calculation also show that not in all cases a Prandtl-Witch failure mechanism occur. In fact, in many cases, other failure mechanisms occur. This is one of the reasons why most of the currently used inclination, shape, and slope factors are not correct. In many cases, the currently used correction factors are too high, so unsafe. Therefore, based on the finite element calculation, new equations have been presented in this article for some correction factors, for example, the inclination factors and the cohesion slope factors, and analytical solution is found.
Okay, thank you very much, Amna. Now, these are the conclusions which are obtained based upon the numerical analysis, numerical modeling, and the physical model tests. Then you compare the data and you come up with the conclusion that you won't see the Prandtl-Witch for each and every soil. So there would be a difference. Now that difference, how much that difference would occur, that is the part of the research which we will do. That is one project. There is another project which comes into my mind. That is which I also discussed with the chairman Saab, that I want to build a few geotechnical or soil mechanics demonstrations models for the soil mechanics lab, and that would be a huge contribution because it would be, you are adding value to the soil mechanics lab. So this is one example. related to the flow lines and flow net. Okay. I will provide the finances for these models. Can you hear the voice in the video or no?
No, sir.
No, sir.
Okay, now it stopped, but how about the earlier one? So you studied about the flow nets in the Geotech 1. Now you got seniors, and now you need to contribute to the department. So if you remember like that, the flow lines occurred and the equipotential lines, you can draw. And the water levels on the upstream side and the downstream side. Now if we place the sand there, and if we saturate and if we add a kind of color there, then the flow lines or the water particles will move from the upstream side towards the downstream side. So we can use the glue there, the drainage and the inlet and the outlet walls there. Let's put the water inside. That tank is in acrylic glass. And you can put those potassium permanganates there. And you increase the head of the water on the upstream side. And that differential head difference will cause the flow to occur from the upstream side towards the downstream sides. So this is only one demonstration model which we will place at the soil mechanics lab. There are dam failures, liquefaction models as well, the bearing capacity models as well. So we can come up with like approximately 7 to 10 models, and in your thesis you are going to explain the basic theory and mechanism which is occurring in this model. So it will refresh your concept related to geotechnical engineering, particularly for those students who are having interest in the geotechnical engineering. That will showcase your talent in front of the chairman and honorable dean and vice chancellor, that we have made these models which are the core concepts related to the geotechnical engineering. Furthermore, you can also send these videos to the international professors and supervisors. Okay, I saw somewhere that video of the bearing capacity, but anyways, it went away. I thought maybe I will catch that so that I can show you. So that was another type of model which I was expecting from, yeah, here, this one. This is the kind of, soil improvement techniques. Oh no, you see those ads, funny ads. So now if you load the soil, you will see the shear failure there. And if you provide some confinement, then it will hold. So now you can see that if we have reinforced these soils with different layers like geotextiles and geogrids, there is also a model for the geogrid and there is also a model for the geotextiles. So you can make the videos, you can take the pictures, and you can include in your final year project. And then you can present these videos during the FYP presentations and progress presentations, which will definitely help. Mechanically stabilized walls are there, in retaining walls these concepts are used. These type of mechanically stabilized walls which are located on the motorways and highways, they are stabilized using the same concepts. So all these information you can include in your thesis.
सर सोइल में भी reinforcement यूज होती है?
Sorry,
सर सोइल में भी reinforcement यूज होती है सर, वो जो वीडियो में दिख रहा है?
वो बहुत ज़्यादा सॉइल में बहुत ज़्यादा रिइंफोर्समेंट की जाती है। सॉइल में तो इतनी भी इसमें जियो टेक्सटाइल होते हैं, जियो ग्रिड्स होते हैं, इवन के लोग जो है ना स्टील रिइंफोर्समेंट इस्तेमाल कर रहे हैं अभी। स्टील रिइंफोर्समेंट के साथ अगर शैलो मिक्सिंग की जाती है, सीमेंटेशन की जाती है, ग्राउटिंग की जाती है, पाइल्स इंस्टॉल की जाती हैं, ये सारे जो मेथड्स हैं ये सॉइल इंप्रूवमेंट के मेथड्स हैं जो कि अप्लाई किए जाते हैं। और इसके पास जो है ना वो इलेक्ट्रोकाइनेटिक्स हैं जो कि सिंगापुर में इस्तेमाल होता है। इलेक्ट्रोकाइनेटिक्स में इस तरह किया जाता है कि दो रोड्स को लगाए जाते हैं, मेरीन इन्वायरमेंट में उसको किस तरीके से जो है ना सॉइल इंप्रूवमेंट की जाती है। बहुत सारे उसमें हमारे पास इनोवेशंस अवेलेबल हैं। डिपेंड करता है कि सॉइल की कंडीशन क्या है, कहीं पे मार्शी कंडीशन है, कहीं पे ऑफशोर की कंडीशन है। एनीवेज, तो ये मॉडल्स जो है ना ये इस पे हम फिर डिस्कशन जो है ना वो डिटेल में करेंगे। अगर आपका इंटरेस्ट बिल्ड होता है तो हम इंशाल्लाह इस पे स्टार्ट ले सकते हैं। और इसको अगर आप, मैंने बताया जिस तरीके से कि इन चीज़ों को बनाना है, इन मॉडल्स को बनाना है, और इसमें भी आपके हेल्प के लिए मैं एक MSc का स्टूडेंट है, वो आपकी हेल्प करेगा। जो बंदा इसको बनाएगा वो भी आपको वो दिखाएगा कि यहाँ से आप ये मटेरियल जो है ना ले सकते हैं। बेसिकली आपने इन मटेरियल्स को जो है ना वो फॉलो अप करना है और वहाँ से फिर लेना है और सॉइल मैकेनिक्स लैब में लेके आना है कि उसमें जो है ना वहाँ पे डाल सकें और इसको डिमॉन्स्ट्रेट करना है। 1-2 बार वीडियोस जो है ना वो बनानी है और उसके ऊपर उसके पीछे जो बैकग्राउंड थ्योरेटिकल नॉलेज है उसका कुछ बायो देना है, थोड़ा सा इंट्रो देना है कि इसमें हम जो टेक्निकल मॉडल्स बनाएंगे तो ये आपका इंट्रो हो जाएगा। इसमें इस टॉपिक के रिलेटेड हमारे पास जो टेक्निकल के मॉडल्स होंगे और फिर ये जो है ना मेथोडोलॉजी किस तरह की, कहाँ से आपने जो है ना ये मटेरियल लिया, कौन कौन सा मटेरियल्स लिया, किस किस मॉडल में कौन कौन सी मटेरियल इस्तेमाल की गई। और फिर उसके बाद जो है ना वो रिजल्ट्स एंड डिस्कशन में आप ये डाल सकते हैं कि फाइनली हमारे पास ये रिजल्ट्स आ गए कि हमने ये मॉडल बनाया और इसमें जो है ना ये हमारे पास डिफरेंट जो आपने पिक्चर्स दी होंगी वो पिक्चर्स आप शो करेंगे। तो चेयरमैन साहब ने इसको बहुत ज़्यादा जो है ना वो अप्रिशिएट किया। उन्होंने कहा कि ये होने चाहिए क्योंकि हमारे सॉइल मैकेनिक्स लैब को थोड़ा सा अच्छा करना है और इसको हमने कोशिश करनी है कि बेहतर कर सकें। तो ये जो मॉडल्स हैं ये मेरे जहन में आए, एक आइडिया आया और उन्होंने कहा कि इसको अगर आप FYP प्रोजेक्ट के तौर पे स्टूडेंट्स को दे दें तो ये स्टूडेंट्स के लिए भी अच्छा होगा और डिपार्टमेंट के लिए भी अच्छा होगा और एक बहुत बड़ी कंट्रीब्यूशन होगी स्टूडेंट्स की साइड से और आपकी साइड से। तो ये देखें, ये अभी यहाँ पे वो जियो ग्रिड्स और जियो टेक्सटाइल्स के कॉन्सेप्ट्स को एक्सप्लेन किया जा रहा है कि सैंड को अगर आप इस तरह करते हैं, करीबन आप कपड़ा रखते हैं, इसको कम्पैक्ट करते हैं। ये भी बियरिंग कैपेसिटी के साथ रिलेटेड है। आपने इसी तरीके से मॉडल बनाना है, इसी तरीके से वीडियो बनानी है और इसी तरीके से शेयर करना है। अब ये देखें, ये अभी स्टील की रिइंफोर्समेंट मच्छरों के लिए इस्तेमाल होती है, मच्छर अंदर ना आए। बंदा खड़ा होता है तो बंदे का वेट ले लेता है। इसी तरह ये चीजें जो है बैकवेट्स में इस्तेमाल होती हैं। गाड़ी के नीचे भी इसको आप लेके आते हैं। इस तरह के स्ट्रक्चर फील्ड में रिसर्च हो रही है, डिफरेंट किस्म के ब्रिक्स बन रहे हैं, ब्लॉक्स बन रहे हैं। इसी तरीके से अगर आप इस चीज को थोड़ा सा हाईलाइट करें तो आप इसको किसी कॉन्फ्रेंस में भी पब्लिश कर सकते हैं। इसकी जो कंप्रेसिव स्ट्रेंथ है वो आप इसकी इवैल्यूएट करें। تو یہ ساری آپشنز جو ہے نا اویلیبل ہیں، لیکن اگر آپ کا انٹرسٹ اس سائٹ پہ آتا ہے تو پلیز جسٹ لیٹ می نو، جسٹ سینڈ می این ای میل.
سر یہ تو پہلے ہو چکی ہے، تو ہم کیوں کریں گے سر؟
دیکھیں اس کا مطلب یہ ہے نا کہ فرسٹ آف آل یہ ہو تو چکی ہے، لیکن ہمارے پاس موجود ہے. یہ اسٹوڈنٹس کے پاس تو یہ چیز وہ تو نظر نہیں آتا نا. یہ تو ابھی میں نے آپ کو دکھایا کہ یہ ہو رہی ہیں. آپ نے کہا کہ سر سوئل کی ویو ہوتی ہے، آپ 6 سیمسٹر میں، لیکن آپ کو آئیڈیا نہیں ہے. ابھی ایک ویڈیو دکھائی، ابھی آپ نے ڈائریکٹلی میں نے مائنڈ چینج کیا کہ یہ تو آلریڈی ہو چکی ہیں، اب یہ کریں. مین چیز یہ کہ یہ اسٹوڈنٹس کو دکھانے کے لیے یہ ماڈل ضروری ہے کہ یہ ریسرچ ہو سکتی ہے. یہ ریسرچ جو ہے نا اتنی، یہ تو وہ بیسکس ہیں، فنڈامنٹلز ہیں جو کہ اسٹوڈنٹس کو دی جاتی ہیں، جو کہ آنے والے اسٹوڈنٹس کو ایٹ لیسٹ یہ پتا ہوگا کہ یار یہ کام تو ہو سکتا ہے، اس طریقے سے بھی ہو سکتا ہے. ٹھیک ہے، تو یہ ایک سٹارٹ ہے اس چیز کو دکھانے کے لیے. دیکھیں کہ اسٹوڈنٹس کو جو فیوچر جنریشن جو آ رہی ہیں ان کو پتہ چلے گا کہ یہ ایسے ایسے کام بھی ہو سکتے ہیں. ڈیفینیٹلی یہ جو ہے نا وہ انوویٹو ریسرچ نہیں ہے، لیکن اگر آپ اس کا امپیکٹ دیکھیں تو امپیکٹ اس کا جو ہے نا وہ بہت زیادہ ہے کہ ایک تو آپ سوئل میکینکس لیب کو کنٹریبیوٹ کر رہے ہیں، دوسرا اگر آپ یہ دیکھیں تو یہ بہت زیادہ جو ہے نا ایک بہت پازیٹیو میسج دے رہا ہے کہ یہ یونیورسٹی یا یہ ڈپارٹمنٹ، یہ لڑکا جو ہے نا وہ جو ٹیکنیکل میں سیریسلی جو ہے نا وہ انٹرسٹ رکھ رہا ہے، کیونکہ اس نے اپنے ہاتھوں سے یہ ماڈلز بنائے ہیں، اپنے ہاتھوں سے جو ہے نا لیکوفیکشن کے ماڈلز بنائے ہیں. لیکوفیکشن کی جو ساری ڈیٹیلز آپ اس میں شامل کریں گے تو یہ ساری چیزیں پھر کنٹریبیوٹ کرتی ہیں. ڈیفینیٹلی اگر آپ اس ریسرچ کے اسپیکٹ سے دیکھتے ہیں کہ یہ اس سائڈ پہ یا اس لیول پہ ریسرچ نہیں ہے، لیکن جو امپیکٹ ہے اس کا کنٹریبیوشن کا وہ بہت سگنیفیکنٹ ہے. باقی بھی اس طرح کچھ ماڈلز میرے ذہن میں ہیں جو ویڈیوز یہاں پہ میں آپ کے ساتھ شیئر کر سکتا ہوں. اچھا، پھر پلاکسس سافٹ ویئر کی ویڈیو میں آپ کے ساتھ شیئر کرنا چاہ رہا تھا کہ یہاں پہ ہمارے پاس یہ جو سافٹ ویئر ہے، یہ اگر کوئی اس فیلڈ میں انٹرسٹ رکھ رہا ہے تو پلیز کائنڈلی اس کو ڈاؤن لوڈ کر لیں. یہاں پہ ایک بندہ ہے، وہ فاؤنڈیشن 2x2 فٹ کی اسکوائر فوٹنگ ہے، اس کو کے اوپر لوڈ اپلائی کر رہا ہے. باؤنڈری کنڈیشن اس کی 10x10 فیٹ ہے. تو یہاں پہ باؤنڈری کنڈیشن لگاتے ہیں. باؤنڈری کنڈیشن کے بعد ہمارے پاس سپیڈ تھوڑا زیادہ کر لوں، اسکوائر فوٹنگ نیم کرتے ہیں، صحیح ہے. یونٹ ویٹ آف واٹر، لینتھ، فورس کی یونٹس وغیرہ کیا ہونے چاہیے. ٹھیک ہے، باؤنڈری کنڈیشن ہو گئی، اسپیسنگ ہو گئی. اسٹرکچرل ایلیمنٹس کو جو ہے نا وہ ڈرا کیا جاتا ہے. جب اسٹرکچرل یا جو فاؤنڈیشن کو ڈرا کرنے کے بعد پھر سوئل کی پراپرٹیز کو کون سا ماڈل استعمال کیا جاتا ہے، مورکولم، ڈرین کنڈیشن ہے، انڈرین کنڈیشن ہے، تو اس کو دیکھا جاتا ہے اور وہ پراپرٹیز جو ہے نا اسائن کی جاتی ہیں. یونٹ ویٹ اور سیچوریٹڈ یونٹ ویٹ کو دیا جاتا ہے. ٹھیک ہے، وہ ویلیوز ان پٹ ہوتی ہیں. پوئزن ریشیو، الاسٹک ماڈولس، کوہیژن، فرکشن اینگل. ٹھیک ہے، ماڈلز میں کافی اچھی ویڈیوز ٹیوٹوریلز اویلیبل بھی ہیں. اس پہ امبیکمنٹس پہ بھی کام کیا جا سکتا ہے اور اس کے سلوپس پہ بھی کام کیا جا سکتا ہے. لیکن اگر کوئی انٹرسٹڈ ہے تو شیلو اینڈ ڈیپ فاؤنڈیشن کی بیرنگ کیپیسٹیز پہ ہم کام کر سکتے ہیں. اس کے لیے فزیکل ماڈلز بنانے ہیں تو وہ بھی بنا سکتے ہیں. وہ بھی سوئل میکینکس لیب میں ہم ڈونیٹ کر سکتے ہیں کہ یہ ہماری ایک کنٹریبیوشن ہے، وہ پڑی رہے گی. آپ 5-10 سال کے بعد آتے ہیں تو آپ فخر سے آپ کہیں گے کہ یہ میرا ماڈل تھا، یہ ہم نے بنائے تھے. اور یہ کہیں جائیں گے تو نہیں، کیونکہ یہ تو 10 سال 20 سال بعد بھی اسٹوڈنٹس کو جو ہے نا وہ ڈیمونسٹریشن کے لیے ضروری ہے. الدو میں نے خود جو ہے نا یہ فلو لائنس کے ڈیمونسٹریشن انڈر گریڈ اسٹوڈنٹس کو کیے ہوئے ہیں کینیڈا میں، لیکن جیسے آپ آتے ہیں تو یہ ضروری ہے، یہ انٹرسٹ کو بلڈ کرنے کے لیے ضروری ہے. کینیڈینس جو چھوٹے چھوٹے اسکول کے بچے ہیں ان کو لے کے آتے ہیں اور پھر ان کو یہ انجینئرنگ میں دکھاتے ہیں، پھر کہتے ہیں کہ اس میں کون سے ایریا آپ کو انٹرسٹ آیا، وہ کہتے ہیں کہ اس ایریا میں مجھے انٹرسٹ آیا، یہ یہاں پہ مجھے بہت مزہ آیا، تو اس پہ میں کام کرنا چاہوں گا ان دا فیوچر، اس سائڈ پہ میں جانا چاہتا ہوں. تو اسکول کے بچوں کو سمر کیمپس لگاتے ہیں اور ان کو الیکٹریکل انجینئرنگ، میکینیکل انجینئرنگ، سول انجینئرنگ میں دکھاتے ہیں. اگر آپ سے کوئی پوچھتا ہے کہ سول انجینئرنگ میں کیا ہے تو آپ اس کو صرف شیکنگ ٹیبل دکھائیں گے اور یہ جو فریم سٹرکچرز ہیں یہ دکھائیں گے، تو پھر تو obviously بات ہے وہ کہے گا کہ یار یہ تو بلڈنگز ہیں، یہ مجھے انٹرسٹ دیتی ہیں یا نہیں دیتی ہیں. تو کسی کے اندر بلڈ ہو جاتا ہے انٹرسٹ، کسی کے اندر بلڈ نہیں ہوتا. اسی طرح ایک آپشنز دکھایا جائے اسٹوڈنٹس کو کہ یہاں پہ بھی جو ہے نا وہ انٹرسٹ اویلیبل ہے، کیونکہ ڈیمز ہیں اور ریٹیننگ والز ہیں، سلوپس ہیں، کیرنگ کیپیسٹی کے ایشوز ہیں. یہ سارے اگر اسٹوڈنٹس کو دکھائے جاتے ہیں، جونیئرس کو دکھائے جاتے ہیں، پھر وہ ڈیسائیڈ کریں کہ وہ اگر اسے طرف آنا چاہتے ہیں یا نہیں آنا چاہتے ہیں، وہ اپنی مرضی ہے، اپنے انٹرسٹ ہے، کسی کو فورس تو نہیں کر سکتے. جس بندے کا جو انٹرسٹ ہے وہ اسی انٹرسٹ کی طرف جائے اور اسی میں ایکسل کرے. ٹھیک ہے، تو یہ مشنگ ہوتی ہے اور اس کے بعد پھر ریزلٹس کو دیکھا جاتا ہے. تو یہ ٹیسٹ اس نے رن کیا ہے، لوڈ ڈیفارمیشن کرو یہاں سے obtain کرے گا. ٹھیک ہے،
سر یہ سمٹائم یہ سر یہ جو سافٹ ویئر یہ ویلیو کی وجہ دیتے ہیں سر، جب اس پر
سوری
پراپرلی ریلیبل نہیں ہے سر.
تھوڑا صبر کریں، آواز آپ کی جناب مجھے اس کی ویڈیو کی آواز آ رہی ہے، تو پھر یہ لوڈ ڈیفارمیشن کرو جنریٹ کرتا ہے اور یہاں سے پھر یہاں پہ کنٹورز بھی ہوتے ہیں. تو آپ کی آواز میں سنوں گا جیسے ویڈیو ختم ہو جاتی ہے. ٹھیک ہے، یہاں پہ کنٹورز بھی دکھائے گئے ہیں کہیں پہ ایک جگہ یہاں پہ. تو یہ دیکھیں یہاں پہ پھر اسٹریسز اور ڈیفارمیشنز جو ہے نا وہ دکھائی جاتی ہیں کہ کہاں پہ اسٹریسز زیادہ لگ رہی ہیں اور اسٹریس ڈیفارمیشن جو ہے نا وہ کہاں پہ زیادہ ہو رہی ہے کہاں پہ کم ہو رہی ہے. ریڈش جو ہے نا وہ آپ کو یہاں پہ دکھا رہے کہ سب سے زیادہ ہو رہی ہے. ٹھیک ہے، تو یہ سافٹ ویئرز ہیں دیٹ یو کین یوز فائنڈ آؤٹ دی بیئرنگ کیپیسٹی آف دا سوئلز ایز ویل. اس کو ہم کریں گے. پلیکسس ایز اے ہول سافٹ ویئر ہے، وہ کتنا پاورفل ہے اور اس کو کیسے ہم استعمال کر سکتے ہیں وہ یہ ویڈیو میں اویلیبل ہے. Okay, thank you very much. We will have a question and answer session at the end of the class, so please stay with us till the end of the class. Now, that was related to the Meyerhof bearing capacity equation, how important it is, how are the different depth factors, shape factors, and inclination factors are derived based upon the research. So these are the inclination factors, and the inclination factors, how we can find out the inclination factors. The difference between the Terzaghi's and Meyerhof bearing capacity approach. So as we discussed, the shear failure mechanism is different. The introduction of SQ, which is the shape factor due to the surcharge, that was introduced by Meyerhof. Now, for depth of the footing, if it is approximately equal to B, the Meyerhof and bearing capacity and Terzaghi bearing capacity will give identical results. But if the D by B is greater than B, then the results of both these theories would be different. Terzaghi's equation is preferable in case of cohesive soil where we are having shallow foundations, and it can give us the quick estimate. And as we know that horizontal forces, tilted bases, and the sloping ground, these scenarios are not suitable for finding the bearing capacity using the Terzaghi's bearing capacity equation. However, in case of the Meyerhof, we can use that equation for any situation or any scenario. There are additional considerations. For example, if we remember that we were given with the 3 load settlement failure modes: general shear failure mode, local shear failure mode, and the punching shear failure mode. Now, the Terzaghi's bearing capacity equation or the Meyerhof bearing capacity equation. Sorry, it's bearing capacity C. Okay. Meyerhof bearing capacity, they use the general shear failure mode of failure. Okay. In case of the local shear failure, there are few additional consideration that cohesion should be reduced to 2/3 by the factor, and you can also multiply 2/3 into the tangent phi in order to account that for local shear failure. Now, general observation about the bearing capacity equation. So as we already discussed that the CNC part is predominant in cohesive soils, and the overburden part, which is NQ, is predominant in cohesion-less soils, like for clays, this one, and this one is for sands. Self-weight of the soil is predominant for both the cohesive and cohesion-less soils, and for B less than 3 to 4 meter, it can be neglected. Now, there is an interesting concept which we touched a little bit about the B prime, the use of B prime, which is the effective width of foundation. Now, for example, we are given with the foundation please confirm that you can hear me and the screen is visible.
जी सर.
Thank you. So this is the width of the foundation, and here is the length of the foundation. For example, there was a central load, so we can call that as concentric load. If this load is acting at an eccentricity E, eccentricity, so pronounced slightly differently, eccentricity, but it's easy to say eccentric, so we can call that as eccentric load, because there is eccentricity of EB, and that is in direction of B, and here we are given with the eccentricity of EL. Now Meyerhof proposed that there will be an area, okay, let me highlight that as the yellowish one. So this area should be ignored due to the eccentricity of the loading P. Now we will come up with a new dimension of L prime. So this would be the L prime, and this one let's suppose this one is the B prime. Now if you want to find out the EB, which is the eccentricity and the along the width of the foundation, and if we divide it by the vertical load, so this will give us the eccentricity in the direction of the width of the foundation. This would be the moment along the length of the foundation divided by the vertical load. It will give us the eccentricity if we want to find, if the vertical load is given. Now if you want to find out the B prime, that would be equal to the B and 2EB, and if you want to find out the effective length, it would be L minus 2EL, and this maybe I think so we need to correct this equation in the notes. Then we will come up with the effective area, and we can find out the AF is equal to B prime into L prime. We will solve these problems in the coming lecture. So there is a separate lecture on solving the numericals, where we are going to use all these equations, and I hope you will understand the concepts more clearly. Now if there is an eccentric load is applied onto the foundation, there is a load is applied, and this is the, let me draw that. So this is the center of the foundation, and the resultant vertical load P is applied at a certain eccentricity E. Then what would happen? Moments would be applied in this direction, and the pressures beneath the foundation would have a distribution something like that, which will give us Q prime and Q double prime, where Q prime is equal to the largest bearing pressure and Q double prime is equal to the lowest bearing, how would call that as bearing pressure. Okay. E is the eccentricity from the central loading, and the question and answers will be given a separate time at the end of this lecture. Okay, please hold on to these questions. Now Q prime, Q double prime, and the Q and E and B are given here as well. Now, for the behavior of clays, for example, drained and undrained loading, these concepts are related to the Geotech 2. Now, for drained loading or consolidated undrained behavior, for normally consolidated clays and over consolidated clays, what you remember from the drained consolidated undrained behavior, for normally consolidated clay and overly consolidated clay. Any thoughts related to CU test on normally consolidated clay and over consolidated clay would be appreciated. And let me tell you that if you are contributing in the discussion, extra marks will be given or extra care will be given in the rechecking of the papers, quizzes and assignments to especially those students who are contributing in the discussion or who are voluntarily discussing the concepts, or whenever it is requested to contribute in the class in terms of the discussion, those students will be given few extra points. Or consolidated undrained behavior. Now we studied in our Geotech 2 course that if we are having a normally consolidated clay, or loose sand, and this is the sigma D, which is equal to sigma 1 minus sigma 3. And if you want to draw the axial strain versus sigma D, so the stress strain curve in consolidated undrained triaxial test would look like this. And then if you want to draw the pore water pressure, so as the soil particles are in loose state and they are compressing, and when they are compressing, the pore water pressure will be positive. Now, if you want to draw for over consolidated clay or dense sands, this would be the sigma D or epsilon A. So the stress strain graph should look like a little bit higher than the previous one, because these are the loose sand, so it should look like this. and then there is a pore water pressure like positive and then decreasing trend will start with the dense sand. And after that, there will be another, for example, OCR is equal to 1, OCR is equal to 2, or OCR is equal to 3. Now, this is the positive pore water pressure, and here we are getting the negative excess pore water pressure. And in case of the increasing OCR, the trend will go from the compressive, from here compressive to dilative 1. If you want to draw the sigma D and epsilon A curve in consolidated drained condition, so we are talking now about the volumetric changes. So the stress strain graph will look like somewhat like this, and it should go beyond that because it's for the normally consolidated clay or loose sand, but here only the concept of dilatancy or the volumetric change is shown, and we can clearly see that the peak in the dense sands are occurring at small strains for OC clay or consolidated clays and dense sands. So the observations were made, which were discussed in good detail in class as well and in the exams as well. We also touched a little bit about the total stress analysis and the effective stress analysis. Now, in case of sands, we do total stress analysis or the effective stress analysis. We do effective stress analysis and that is also known as the long-term analysis, and that is also known as the drained analysis. Now in clays we do, sorry, now in clays we do the short-term and both long-term analysis, short and long-term analysis, because we are also given with the normally consolidated clays and over consolidated clays, and in over consolidated clays negative pore water pressure will occur, and we need to provide sufficient time to equalize this negative pore water pressure, because this negative pore water pressure is giving added strength to the soil. So therefore we need to do the long-term or drained analysis or effective stress analysis in case of OC clays. Information is given here that we need to perform total and effective stress analysis, and how we perform the SCU, the undrained shear strength of the soil, shear strength of the soil, and the undrained shear strength of the soil was, we can also obtain it from the vane shear test, unconfined compression test, unconsolidated undrained test, triaxial test, and different types of triaxial test, CU tests. Now An example is presented here as well, as we discussed in the Geotech 2 course regarding the examples for different types of test and the field application. So here is the oil tank, and here we are given with the grain elevator, so where we can store the grains here. For example, if we empty this tank, and here we are given with the saturated soil beneath the foundations, and here also we are given with the soil beneath the foundation. So if we empty these grains out of this tank and the oil out of this tank, and then we fill it, this oil has already consolidated the soil beneath the foundation. Now suddenly emptying this elevator or emptying this tank and then refilling this with the oil and refilling the grains, the elevator with the grains, will cause the consolidated undrained test, because it was consolidated initially. Now we are adding extra load on top of this tank or the soil. Now that is in undrained condition. Effective shear strength parameters C prime and phi prime. The discussion is already provided here that for normally consolidated clays, we will perform the short-term analysis, because we will have the lowest strength in the short-term analysis or the undrained analysis, or we can also say total stress analysis. And if we remember, we already know that for phi equal to 0, if we solve this equation of the Terzaghi's bearing capacity equation, we will come up with an equation that will give us that Q ultimate net is equal to the Q ultimate of this soil, approximately. Okay. Now for heavily over consolidated clays, we need to perform the effective stress analysis. And the reason behind that is the negative excess pore water pressure which is generated. So that is adding to the shear strength of the soil. For the lightly over consolidated clays, what we need to do the total stress analysis and also the effective stress analysis. One thing which I need to mention here, that for sands, we sometimes do undrained or short-term analysis as well, but whenever we are sure that we are having an issue of blast loading in sands or earthquake loading in sands, and this will cause liquefaction problem. One of the model is to explain the liquefaction in sands, which is also related to the Mirpur sand, because Mirpur embankments were liquefied during the recent earthquake. Now, going towards the design philosophies, there are two design philosophies. One is the allowable stress design philosophies, and that concept we already discussed in this chapter, that we find out the Q ultimate, and Q ultimate we can find out using Terzaghi's bearing capacity equation, and we can also find out using Meyerhof bearing capacity equation or theory. Agree? Then we use cohesion and friction angle, the shear strength parameters, and these parameters we find out from various tests, I would call it, various lab and field tests. Sampling disturbance, collection, apparatuses definitely play a huge role in getting the ultimate bearing capacity of the soil. Now, if you want to find out the Q allowable, we use the factor of safety of 2.5 to 3, and based upon all the uncertainties which we see here, we just apply the lumped factor of safety. We divide that Q ultimate divided by the factor of safety, and we get a Q allowable. Now there is applied load on the foundation, and the allowable stress design says that the Q applied should be less than or equal to the allowable bearing capacity of the soil. Now, why we apply factor of safety? That is already communicated in great detail and discussed in great detail, that there are few loading conditions which are different, soil types, soil site investigation, soil variability, and the importance of the structure and the consequences of the failure are also very important. There is also another foundation design philosophy which is known as the ultimate limit state. And the ultimate limit state, we apply partial factors to the load and to the shear strength parameter. How we do that? That loads are multiplied with the factors which are recommended by the different building codes, and we get the factored applied pressure, and then if we divide this factored load by the base area of the footing, so we will get the factored applied pressure. Design shear strength parameters are calculated by multiplying the shear strength parameters of the soil by the resistance factors. So there are resistance factors, are the factors which will reduce the shear strength parameters, are known as the resistance factors. For example, if you want to list few factors, the load factors 1.25, 1.3, 1.5 for the live load, wind load, and seismic load. It means that dead load is increased 25%. Whatever the structural engineer calculates the dead load of the structure, you need to increase that by 25%, and 50% you need to increase the live load of the wind and seismic loads. Now the resistance factor, which are Fc or F gamma, please confirm that you can hear me.
Yes, sir.
Okay, the resistance factor 0.8 is applied to the friction angle, and 0.5 to 0.7 you need to multiply it with the cohesion. So basically we are reducing this friction angle value by 20%. So now whatever apparatus we use, so we have already reduced the friction angle value by 20% because we are using the resistance factor. This is good or on the safer side in one way, but it can be severely conservative on the other side, because these parameters will significantly affect the dimensions of the foundations. And we are reducing 30 to 50% reduction is applied onto the cohesion of the soil. Now, the design capacity based upon the ultimate limit state, the design capacity should be greater than or equal to the factored applied pressure. So that is the philosophy which is related to the ultimate limit state. Now, we will mainly focus on the first design philosophy, which is the allowable stress design philosophy, in our today's class. So thank you very much for listening very patiently. Now we will move towards our question and answer session. Thank you.